Good morning, and thank you for joining this session. I know there are a few sessions going on at the moment, so you come into this room, that means a lot. I really appreciate it. I only have 20 minutes, so I want to jump right into the topic. First of all, can everyone hear me okay? Is the voice good? Okay, awesome. All right, yeah, so you heard the long bio about me, but the short version of that is that I've been with AWS for a little bit over 6 years. My main role is that working with the startups around the globe. Every year I work with tens of thousands of startups, helping them to build, grow, and scale on AWS. Prior to that, 20 years of working across different industries, which is obviously that requires a drink to kind of talk about this, but it's not about me, it's about a talk. So let's jump into that. The topic for today is LLM, multi-LLM routing strategies. And the reason that I've chosen that is basically, it was an hour talk, but I decided to kind of shorten it to 20 minutes. So would be very much focused on a very high level architecture and best practices on when you want to use multiple foundational model for your application. And it's mainly based on the best practices that I've seen for the last few years, working across with different hundreds of startups. That's typically how I've seen they're doing it. So let's jump into that. For most of you who have ever created any generative AI functionality into your product, in any use case that you might have, you might have agree with me that the challenging part to start a project is to choosing the language model. Which model is the right thing that I should start with? What I've seen as a best practice is that typically the teams and companies start to pick a model based on their observation from the public internet or searching or hearing from their colleagues, and then start to do some benchmarking, some testing, doing some main criteria, and then based on the outcome they pick that model. That's definitely work. But would that be sufficient? Definitely not. What we've seen is that as your product evolves, and it's not necessarily the first language model that you choose, it's not necessarily the right one. Your requirement evolves, your user expectation changes, and then the model that you've chosen may not correctly perform for the different requirements. And one of the examples is that some models perform well when you want to do some reasoning, some text summarization, but at the same time, they expose some security risk or some hallucination. That's why one of the good practices that I've seen is that companies start to switch into multiple LLMs. There are different use cases, if you want to go a little bit deeper into that, in terms of what are the cases that we might need some best use cases that we need multiple language models. One example is that your application is doing a task, and that task has different types. For example, imagine a content marketing application. There are some content marketers who will start to creating some headlines, some ads, some keywords, and then they need different feature, but at the same time, there are different person in the same team that do the insights analysis based on the ads performance. And then there is a business unit to do the business analysis. So based on that different types, you might want to tune into different model. The other version of that is that when there is different complexity, imagine a chatbot for academic. If the students ask for some questions, you might do some simple search. But if they need deeper research, then you need to go deeper and do more thinking behind the scene. And that's where you need to use a different model. Another option is a domain specific. A big enterprise, sometimes they have different business units and operations. For example, they have finance, they have legal, they have HR. And for every single task, you might choose different models to do it. And ultimately is the SaaS application. If you have different offerings for different tiering based on the pricing, that's where you want to switch into different models. For example, imagine a resume review application. When you upload your resume, the initial thing that the website is doing for you is that do some overall analysis and tells you that, what are the areas of improvement. And then if you want to actually do the write-up for the new LLMs, that's where you need to switch into different models because that's part of the paid tiers. All right, so this multi-LLM approach obviously going to give you different benefits. By implementing a suite of complementary models and aligning them together and do proper integration, you would be able to kind of, depends on where the focus is, the cost optimization or is the security enhancement, you can achieve multiple benefits. You can improve the complexity by reducing it and make different layers of application to tune it into different layers of different models. But we know that it's very simple to say that it is easy to do it, but it comes with some challenges. The first challenge is that the first and most important layer of the application, as soon as you introduce new models, is that how I should route to different models, is that what is the logic here? And there should be a very sophisticated routing logic inside your application to decide that for prompt A, I'm going to send it to model A, and for prompt B, I'm going to send it to model B. So this classification introduces some overhead. And that obviously, extra layer, extra processing, so might be some performance degradation. And last but not least is that the consistency issue. Not every model performs the same for the same prompt, and that's what we know. And that's the whole idea of using language models, because we don't want that determination to be 100% right all the time. Let's look at some of their strategies now. We talk about a high level of what are the benefits, what are the cons, but when it comes to the implementation, there are different ways to do it. I'm going to talk about three main strategies for this kind of multi-LLM applications. The first one is static routing. As its name says, it's very simple. So you basically have different components, UI components in your application, and it's directly tied into a language model. The example that I have here for you is that content marketing. Imagine there is a team that has some people in the team required to do some text generation for generating new ads, new blog articles, headlines, and those sort of things. So that UI component directly links to a specific model that is good and optimized for the text generation. In contrast, there is another team, and that team wanted to do some insight analysis to see how the ads are performing. So the UI component is linked to another one. And then completely different unit in that company might do the business analysis, and they need to do some text summarization on the output and on some performance data. As you can see here, the benefits are obvious. It's very simple. It's very easy to add a new feature to the application, because you create a new UI component, link it to a model that you wanted to perform, and then add it to the application. But the disadvantage of this model is that it is not flexible enough to be able to constantly evolve your prompts, and as the new prompts comes in, it would be very hard to be able to integrate something new, because you need to release a new version of your application. This approach, the cost is ideal if you have a very simple solution, but obviously there are better ways to do it. Alternatively, you have something called dynamic routing. And dynamic routing, there are many ways to implement it. As its name clearly says, you have a layer in between your application, your user interface, and also your models that does this routing logic for you. Basically, imagine this is an example for customer service chatbot. A user come in and ask for a question. I have a problem with my laptop or something like that. And then your routing layer decides at which department in the organization it should be routed to. Typically, typically one of the benefits that you get immediately out of the box is that that can cater for many forms of prompts. It doesn't need to be hard-coded. So your routing layer gonna make that hard decision about this is the prompt that I'm getting. I'm gonna do classifying it and decide that this is a tech support, or this is a business support, or it's kind of some billing support, and it's gonna route it to that. The benefit that you get out of this is that it's very dynamic. By just fine-tuning your routing layer and adding more code and improve it, you will be able to do proper routing if you see any issues around your routing logic. But at the same time, it's extra complexity because it's less visibility into that. Now, I know that most of you may not be very familiar with AWS architecture or Verbiage, but allow me to use some of them. I try to stay very high level here before jumping into specific services. So I want to show you one example about this LLM-assisted routing and two ways of doing it. Imagine that your user send the first prompt to your system through any interface that you might have. Any form of API management is going to cache that request. It's a REST API, or depends how it's implemented. It's not really important here. A function going to kind of cache that prompt, and then that's where your routing layer is that. is. So LLM-assisted routing is one way to do it, which basically you get the prompt, and then you route your prompt to another LLM, which is not your target LLM, and that LLM is specifically designed to do the classification for you. Use a prompt into the chat and say, I have a problem with my billing. And this classify LLM gonna get that and decides that based on this prompt, I identify this as a billing issue. So I want to route it to LLM for, let's say, summarization or analysis. These are different examples you can use here. Obviously, there are more components on the screen, so that requires more work to build it. But there are, like any other architecture, there are benefits into that. Additional cost is one of the disadvantages because you have extra LLM, you have extra requests sending to your model that needs to be processed. But in contrast, your classifier is able to determine, based on the prompt that it received, to be able to go to the fine-grained level and be able to decide that this question, that these tokens that I'm seeing in this prompt, represent classification A, B, C, and you can do the routing. This is very useful when you want to do the fine-grained routing for your application. And that means that you want to go to the specific parts of your departments or tools, your application that you're building, and sending a specific prompt to the specific cases or LLMs. Another way of doing that is using a semantic routing. I assume that you are familiar with the semantic search, but if you're not, semantic search uses the embedding, text embedding as a numerical vector presentation to be able to do the similarity search with the existing vectors or the prompts. So what does this method is that when you receive the same request, it sends it to LLM first for embedding. Means that it takes a prompt, it sends and embed it and turn it into numerical vectors. And then based on that, it compares it against an existing set of reference prompts in a database, in a vector store. And then once it's decided that which classification is that, it might send it to the downstream LLMs. So cons and pros, as usual. Complexity, yep, there are some level of integration overhead. There are some level of performance degradation. But in contrast, what it does for you is that because it's using embedding, it gives you the possibility to do the broad similarity and do the similarity search with the existing set of reference prompts, which makes it very useful and beneficial for scenarios that you want to do the domain-specific switches. As an example, when someone requested for the technical support in our chatbot example, this text for embedding allows to cover a broad set of keywords or tokens that user prompts into the chatbot and be able to define that this is based on this numerical vector values is good for the technical support case. So I'm going to route it to, let's say, route A or route B. One of the challenges that we see with this is that, apart from the complexity, is that this text, the embedding and also the vector database is another topic that you need to start thinking about it. Which vector database should I use? Which vector store is? And there would be another layer of performance overhead into that. So as you can see, there is no bulletproof solution out there. It's really, boils down to what you are trying to achieve here. And what I've seen that most of the kind of teams that I'm working with that are doing is that taking a hybrid approach. And by that, it means that they use a combined model, combined version of this routing algorithm. Means that when the prompt comes in, the first route it to an LLM for classification, for the semantic search. And based on that, the initial definition, broad categorization, is decided. Is it technical support, is it billing, or is it something else? And then based on that, they send the prompt again or follow-up prompts into another LLM, and that's where it does actually do the more fine-grained analysis to say that this is go to the specific person or team that needs to handle this operation. Cool. So on top of these three methods that I mentioned, for any form of generative AI, multi-LLM applications that you want to build, there are different considerations that you have to take into account. First of all is that you have to constantly improve and optimize your routing layer because the requirements change, your prompts changes, your users might use different prompts, different wording. So it's very important to optimize your routing layer. The other thing is that choosing the vector database is important. We have different options from different cloud providers that gives you the flexibility, depends on how much you want to scale, how much prompts you want to use, what is the existing traffic. So different factors that you have to bring into the account. And ultimately, making sure that the downstream LLMs are chosen wisely because as I said at the beginning of this presentation, every single LLM performs differently, depends on the prompts. So a few areas to consider here. All right, that brings me to the end of this presentation. This is a link to the full blog article that my team has created. So if you want to see the implementation that I just given you, the code, the cost analysis, the cost comparison, and everything else is there. And thank you so much again for joining this session. If you have any question, I will be here on the floor and happy to answer your question. Thank you so much.
Any questions? Actually, I have a question. So how about the latency? I think that's a good topic. Then for the routing, if you use LLM, right, we need to consider about the latency. Have you ever tested about the latency about each method?
Yeah, as I said, the static routing is the one that has the minimum latency, but as you start to add extra layers into that routing layer that you saw, that's where the latency begins. Now, how can you address it? There are different ways to do it. One way is to looking at the downstream, because it's not just one single action in your full architecture that causes the latency. You have to look at it end-to-end. How I receive the prompt, how I do the vector search, how I receive that and send it for the text embedding. Can I use some prompt caching for that? For example, some of the tools that we have already offers this prompt caching, which means that if an existing prompt comes inside that LLM, some of those models like Anthropic or others, they provide this caching opportunity. If they receive the similar prompts, they're not going to go to perform the same search, so they're going to use the caching for that. There are different components into that, but to summarize, any form of LLM-assisted routing, which either through the embedding or anything else, that adds extra overhead to that. But that's why I said at the end that it's super important that you fine-tune your model as your product evolves.
Yeah. Okay, thank
cool.
you.
Awesome, thank you so much.
Okay, there's one more question, I think.
Can you comment on the accuracy?
On the accuracy?
Yeah.
So there were two methods here. I want to make it very short because I know there's another call here, and I'm happy to take it offline with you off the stage. But there are two methods here, right? Where the semantic search is where it allows you to perform the matching with less accuracy when it comes to the routing layer. When you do the LLM assisted, it basically do more like-for-like comparison between your prompts. So the routing layer that you have, there is an accuracy there, and there's an accuracy at the downstream LLMs, and it's totally up to the use case. For example, you might build an application in the legal, it's in the finance, it's in the stock market analysis. There are different models, and each model provides some form of benchmarks that tells you that where it performs better. For example, you look at Gemini, you look at the Anthropic models. They all have this different set of benchmarks that highlights that this in the reasoning, under reasoning or different areas that performs better or outperform the other models. I hope that answers your questions.
Yeah, if you have other questions, you can contact Ethan offline. So I think time is limited. Let's move on to the next speaker. Thank you, everyone.